Hello, everyone. Today, our discussion is going to be on inheritance, which is kind of the core of object oriented languages. There's an excellent chance that if you've learned how to program, even in the Hello World stuff, maybe, that whenever you were using the language like Python or C++ or Java, and you're at the very kind of beginning stages of learning that, that's okay because there's an excellent chance that you may have already been exposed to inheritance and maybe not recognize it. Or perhaps you did recognize it and maybe you're now at the point where you want to learn how to use it on your own. Okay, so with that said, that's what this lecture is going to be about. So, inheritance effectively allows us to make use of code that's already existing because maybe we don't need to recreate it, or maybe some other objects that we're creating are kind of special cases of other ones. And we realize that we can kind of build on other things to kind of scale it up and make our code kind of very structured, easier to read, and more professional looking, I would say. So, what we're going to do in this lecture is I'm going to start out with some pre built shapes, classes associated with shapes. We're going to have a square, a circle, a rectangle, and then we're going to go back and first we're going to start those. We're going to create those in the most naive way possible, where it's going to be explicitly created for each one of them. We're going to make sure we can use those, whatever, and we're all set. Then we're going to kind of build it up from there, and we're going to modify one of the classes, or maybe both. I don't know. We're going to modify the classes, and then we're going to show, hey, using this technique, we can go through and essentially reuse a class that we've already created because a square is a special type of rectangle. And we're going to show that we could just reuse the rectangle class to create the square class. And what that means is we're actually appealing to some of the natural nested things, some of the natural constructions that we have in our real world into code. So let's be clear, mathematics, a square is a special type of rectangle, so we should be able to incorporate that into our code somehow. Well, that's where inheritance kind of comes into play. So what we're going to do is I'm going to kind of build these classes, and I'm going to show you from there how we're going to modify it. So initially, we're going to start out the most naive way possible. So let me transition over to my IntelliJ screen, and I'm going to show you. We're starting out with kind of a clean slate. This is effectively it. We're going to close our POM file. As you can see, all I've got is the kind of the standard IntelliJ boilerplate, whatever. We're going to erase everything and start from scratch. Okay. What I want to do is I kind of want to migrate into a little bit more organization. So what I'm going to do is I'm going to go here and I'm going to create a new package so that way I can keep everything kind of together, and I'm going to call it shapes. All right, so I'm going to create a new package called shapes. Inside of this package, I'm going to create a Java class for a square. I'm going to create a shape. I'm going to create a class for a rectangle. And I'm going to create a class for the circle. Okay, so we've got a circle, a rectangle, and a square. Okay, so I think let's start off maybe with the rectangle. So the rectangle is going to be kind of the easiest. Now, one of the important parameters about a rectangle, we know that there is we're going to call it a double, where we're going to have a length, and we're going to have a width. So the reason I'm calling these private, I want to be able to set these inside of my class. The reason that I'm saying that they're final is because I don't want them to be updated. Once I create my shape, I don't want it to be modified in any way. And then the double is just so we can have fractional values, integer values, whatever we want, just kind of a value effectively. So now what we have to do is we're going to go and maybe create our constructor class, and it's going to be public rectangle, and we're basically going to pass in the values for the length and width right away. So it's going to be double length, and it's going to be double width. Okay, so if you're working with me, you just start a new project, you basically just repeat what I'm doing and you'll be all set. I'll make all this code available for you to look at on GitHub if you want to, but for right now, if I was you, I would open up IntelliJ and I would just do it as I'm doing it, so that way you're well familiar with what we're doing here. So whenever we call our constructor, it's basically just going to take parameters and it's going to set these class variables for us. So it's going to be this dot length equals length. Okay, very simple stuff. This dot width is going to be equal to width. Now again, this means it's going to be this variable, this white one without this means it's coming from the parameter. So we're using the parameter to set the class variable, as we've done many times in the past. Okay, so we've got that. Not a big deal. Now, since we declared these as private and final, we're going to have getters for these. So we're going to say maybe public double get length. See how IntelliJ is trying to help us out here, I guess. And we're going to have return this dot length. Then we're going to create one for the width. So we're going to say double get width, return this dot width. Okay, so we got our getters and setters. Now what I want to do is there's two things about a two-dimensional shape that's going to be true for all these shapes. They're going to have a perimeter and they're going to have an area. So what we're going to do is we're going to do public double get area. Okay, so on this we're going to return what is the area of a rectangle. Well, it is just simply the length times the width. Now again, we don't have to use this here because whenever we had to use this here to distinguish between the class variable and the parameter. Now down here, there is no kind of hang up on which one it was. If you notice, I could have just deleted this and it would have been fine. So if you want to just be consistent, we could have this dot length and we could have this dot width. Okay, so that kind of keeps everything all nice and tidy. Now we've got the area. We want to have the public double get perimeter. Okay, so now we're going to return what is the parameter. It's going to be 2 times the length plus 2 times the width. Okay, now what I want to do is I want to have something that'll print out a nice neat little report for my shape here. So what I'm going to say is I'm going to say public string. Let's suppose we're going to say toString, because that's what gets called when you ask to print a class. All right, so I'm going to start this out by saying SB string builder. You actually don't have to use a string builder here since we're kind of building it all at one time, but we'll just keep it here. String builder SB is equal to new string builder. Okay, and we're going to put shape information and details. Okay, so that's going to be our starting line. Then from here on, I'm going to do sb.append, and I'm going to have new line tab. I'm going to put shape. Oops, sorry, rectangle. This is a rectangle. Okay, now I'm going to do dot append, and for each one of these things, we're going to go down here, and we're just basically going to give all the parameters there. We're just going to return back. So it's going to label the shape, then it's going to print the information. We're going to have the length, the width, the area, and the parameter. So what I'm going to do is I'll pause the video here just for a second, then I'll type all that out and let you guys see when I. Okay, so I've created all these things that we're going to print out for the rectangle. You'll see it's going to say, oh, this shape is a rectangle, its length, its width, its area, and its parameter. So now that I've got all that there, remember I used a string builder to do this. So instead of a string builder, I'm just going to return back a string. So basically sb.toString, so we had to return this, sorry, return. And then we're all set. So we've effectively created our rectangle class. So let's go over here to main and let's see if we can use it. So notice here, whenever I do rectangle, IntelliJ is going to try to help me out. See, it's recognizing that I got a rectangle here and it knows that it's in my shapes package. So watch what happens. Back before I didn't have to do this because now we're in our shapes package. Now we're going to have to import that package. But watch what IntelliJ does when I select this. Notice that it imported the rectangle for me. So I'm going to say rectangle 1 and new equals rectangle. Now we got to pass in a length and a width. So I'm going to say let this be a 4 by 3 rectangle. And then what I'm going to do is I'm going to say system.out.println print this information about this rectangle, and then let's see what happens. Okay, so I'm actually going to pull this up here so that way we can slide it over occasionally. Alright, so here's what it's printing out. So when I run this code, it says shape, information, and details. The shape is a rectangle, length is 4, width is 3, area is 12, perimeter is 14. So that makes sense, right? 4 times 3 is 12, and then 6 plus 8, we get these details, 14 for the perimeter. So everything seems to be working out just fine. So let me close this back. All right, so we got our rectangle. It seems to be fine. Let's now go to our circle. So our circle, we got just a little bit of a difference here. What is it about a circle? A circle has a radius. So we're going to do private, final, double, radius. All right, now what we're going to do is we have to, the reason IntelliJ calls this red is because right now we have no way of setting it. This is why are you doing this if you're not setting it to anything? So we're going to say circle, actually, public, circle, and we're going to pass in the radius, and we're going to go through and basically set that. So this dot radius, using the constructor, radius. All right. Now we're going to have a getter. There's only really one parameter to a circle, so but we can actually do two things with it. We can get the radius, we can get the diameter. So let's do something for both those. So public, let's see, yeah, public, double, get radius, and then we'll return this dot, having trouble typing today, radius. Now we're going to have something called public double get, what do we got here? Get diameter. Okay, and that means we're basically just going to do 2 times this dot radius. Now we're going to create a class where we're going to say get the area. So public double get area. So what is the area of a circle? If you guys remember, it's pi r squared, right? So we're going to return. Now here's where we have something that's a little bit different. So it's going to be pi. The way we do pi, the way we do constants in IntelliJ is we check to see if something is already present. Dot pi. If you notice, there's a pre-built double there that we could use that kind of makes the precision as good as possible. So we'll just use that. It's going to be pi times the radius squared, but we won't do the power function. We'll just do it twice. Radius. Okay. So pi r squared. Now we're going to do the circumference. So we got public double get circumference, and it's going to be return. Now on this one it's going to be 2 pi r, so it's going to be 2 times math dot pi times the radius. Okay, so now we got all those things. Now we're going to create our toString function again. Public string to string, open it up. Now what I'm going to do is I'm basically going to pause the video and I'll populate this. You guys will have to sit there and watch it, and I'll be right back so you can see that I put all the items inside of there. So we'll pause. Okay, so we've got all of that information here. We got the circle, the radius, the diameter. I guess I could close this so you guys can see everything. We got the radius, the diameter, the area, and the circumference. Okay, so what I'm going to do now is I'm just going to return sb.toString. Okay, so now we've got our circle absolutely complete, right? So we got our circle absolutely complete. Now we're going to go over to our square. Now our square, I want everybody to remember, our square is absolutely kind of a rectangle. That is the definition of it. A square is a special case of a rectangle. Except that the square, instead of having the 2 sets of sides are the same, all 4 sides are the same. So we could go through and we could absolutely create the square by defining each one of these. So instead we'll have a square where we'll have just a side length, and then we will effectively have all of these getters, except instead of a get and a width, we'll have just maybe get side length. Then we'll have the get area, the get parameter, just as we had before, and then we have the toString where it's going to print out all the information effectively, right? Okay. Well, if we really think about it, wouldn't it be nice if we could just maybe use the rectangle? Since the square is a very special case of the rectangle, maybe we could just extend the rectangle class to allow a square. So to be clear, everything would work if I have the square. I could absolutely just put in the length and the width being the same value and everything would work out just fine. Except when we get down here, this part wouldn't print out quite right. We'd say rectangle the shape. So that really wasn't all that well. And truly we need something. If we're going to have a class called square, then we really want to be intentional about the way the parameter is. So a rectangle does have two parameters, the length and the width. A square just has one, but a square is a special case of a rectangle. So we don't just need to use the rectangle class by itself. We probably should have something called a square. So let's go ahead and get started on that. We need to be careful here. We have some options. So we could just recreate everything where I'm going to say, okay, we're going to have a we're going to have a private, final, and then we got something called side length. Double. We absolutely could have that. That's absolutely no trouble whatsoever. Okay. The problem is that the square has a length and a width as well. So if you're asking about a square, so somebody might have wanted to use everything that a square has, everything that a square specific to it, but they might also want to have all the things that are associated since it is a rectangle as well for getting the length and the width. So we're in a little bit of a situation where we had to expand out everything here that the rectangle had plus the specifics about a square. It turns out that object-oriented languages make this much easier, much easier, in that we can modify things just a little bit. We could go over here and say square extends rectangle. Okay, and what that basically means is that we're going to keep everything in place for the rectangle. The square will have available everything the rectangle had and anything extra that we want to add. So the first thing that we need to realize is that a square has a length and it has a width, right? So but it also has just one parameter, the side length. So instead of declaring a private length, private, get length, get width, we'll just use one for the rectangle, and then we'll add a getter for side length, but that will just basically get one of the length or the width, and we have the same thing, correct? So what I want to do is I'm doing a lot of talking here, and maybe I've lost a few people with this discussion. So I think an example will be the best way to show this. So first we're going to declare our constructor. Notice that I'm not going to define any variables, and you'll see why I'm doing it in a second. So we're going to do public square, and then here I'm going to put double side length. And so you may say, well, that's okay, but in all the other classes, everything that was a parameter was also a class variable, right? We passed in a length and a double because we had a class length and double. Here we had a radius passed in because we had a radius. Here a square, we don't need to. What I'm actually going to do is I'm going to do this. I'm going to say super, and then I'm going to put side length. Now, take a look at what's happening. When I put super and I opened it, it's almost like I'm calling a method. Look at what IntelliJ is making a suggestion here. It's saying length and double. Whenever you declare super as a method, whenever you're calling the super method, the function that's a super, you're calling the constructor for the class that's being extended. So whenever I say super, so what is square, extends, rectangle, rectangle is the super class effectively, and so when we say super, we're calling the constructor rectangle, which has parameters length and width. But notice that square only has one. So what we're doing is we're allowing somebody to declare a square, but it's really going to use the what class? It's going to declare the double for the length, which is what I'm going to say side length, and then double side length. So if you look and see what's actually happening here, I'm sorry, we don't have to declare it because we're a little bit of an oversight. Sorry about that. We just declare the parent class we're declaring public square, the constructor, But what it's going to do is it's going to take that side length in and call rectangles constructor and pass the same side length into the length and the width to create a square, because a square is a special case of a rectangle. Okay, and that's basically it. Now, you may say, well, we need to have a getter for the length, the width, and all that. Well, it turns out that all of these values are already available, so you'll see that square will have all of this available with no issue because it's extending rectangles. So whatever rectangle has, square will automatically get without having to declare a new one. So what we may need is just to add one more getter that says public, and we're going to say double get side length, and then what we're going to do is we're going to say return this dot. Now we don't have side length, but guess what we do have? We have the get length of the superclass, right? We have the get length of the superclass. So all we're going to do is we're going to declare this, or actually get length. Now, get length. Here's what I want everybody to be aware of. If we use this dot get length, that means get the one that's for the square. If we were to do super, then that means get the get length for the superclass. Now in this case, there's no ambiguous because it's not ambiguous because we haven't defined anything get length on our own. So what we need to do is maybe just leave this alone where we're going to say get length. Or maybe we could say get this dot. Notice that we don't have access to the variables. I'll show you that here in a second. We have get length. Okay, because remember, it could have been just as easy get width because on a square, both the length and the width have been defined to be the same length. Right? So that's the idea. Super calls the constructor of the class that's being extended. All right. Now we have to go down here and we have to make sure that we can do all this. So we're going to say maybe public toString and we need to handle all the specific information for a square. So we're going to do string builder SB equals new string builder, and in here we're going to put shape details. So what I'm going to do is I'm going to pause the video while we go through and create those, and then we'll hop right back. Okay, so take a look at what I just filled in here. I basically just filled in all of the stuff that we want to print whenever we're printing the squares information. So we got shape details, we say shape is a square. Now take a peek. The side length is what we have because a square only has a side length, and then we know all four sides are the same length. What do? We call the thing get side length. Okay, well that may have some overhead to it. Maybe we don't want to do that. Notice that we could basically just do call this get length as well. This will work as well. Then area. Notice that I've never defined area whatsoever up here. Whenever I say this dot get area, it's actually calling the area of the rectangle. It's actually calling the area of a rectangle. But remember, we did the square as a special case of rectangle where we use the constructor of the rectangle by referencing super, and we passed in the side length by the side length. For the length and the width, we just made it the same values. So remember, we can declare a rectangle by just saying that the length and the width are the same thing, and we have effectively a rectangle that is a square. That's what we're appealing to here. And so when we want to get the side length, well, then we can just use rectangles get length, because whether it's the width or the length, it's going to be the same thing. Down here, when we're printing the side length, we just say get length. Not a big deal. Okay. Now, notice that for right now, we're not able to use the variables directly. I just want to point that out one more time. Notice that I cannot do this dot length. Notice that I don't have an ability. We'll get to that here in a second. So for right now, we're using get length. Okay, so just to show you that this is working, we're basically going to call initialize a square. Notice that we're going to import the square. Okay, and then here we only have to pass in a side length, so we're going to say maybe 5. So we know what the perimeter to be. The perimeter should be 20 and the area should be 25. So let's see what happens. Hit a run button. Okay, and notice that the information for the shape square came out. But notice how much little effort we defined our rectangle class where we had all of these lines of code all the way down to line 38, but the square was significantly more abbreviated because we really only had to use what? We could just basically extend the rectangle, and then all we need to do is have a constructor where we use the constructor of the rectangle, where we create our own getter, but we use one of the rectangle's variables, or one of the rectangle's methods rather, and then we created our own toString. So the toString, anytime you define it inside the class, it overrides whatever's inside the rectangle. If we did not have a toString here, watch what happens when I do this. I'm going to comment this out as though it never happened. Now whenever we run this, you'll notice that it's going to hop back to the rectangle. So notice that now it's using rectangle's toString. So without the toString being defined inside the class, it's actually reverting back to the one that's defined in the rectangle. But since we have one built inside of square, it will now take precedence over the one inside the rectangle. And so we will hit play and notice that we go back to the square details we're running. By the way, I moved this output from the bottom over here to the side. You can grab these little icons and move them around. Okay, so that basically shows what it means to have inheritance, where we're extending a class and just utilizing things that are inside that class. Now, we want to say something here that may be a little bit some people are really kind of hawks about having too much overhead. Notice that we could do this. We could say get side length. Now, look, watch what will happen. Whenever I call get side length, it will call this function. This function, since there is no get length inside of square, it will go back and call rectangle's get length. It will be calling this. That seems like a lot of overhead to have functions, getting values, right? So let's suppose that we don't want to have that overhead and we just want to use these variables of rectangle directly. If we know ahead of time that rectangle is going to be used as a class that's going to be extended somewhere else, if we know that, if we know for sure that the rectangle is going to be extended, then what we can say is we want to make length and width available to anything that's extending rectangle. In that case, what we're going to do is we're going to rename these variables to protected, right? We're going to rename these to protected. So let me keep it private just for a second. I'm going to go back down here to side length. Okay, I'm going to go back down here to side length, and I'm going to say get, the length. Notice that IntelliJ is complaining. It says length has private access inside a rectangle. How do we fix that? Well, I had to call the methods because they were public. What I can go up here to rectangle is I could actually refer to this, as I said before, as protected. At this point, we now go back over here to square and notice that there's no longer a problem. So when I hover over this, this is actually the variable that's being referenced, as you notice right here, in rectangle. So what protected does is the protected keyword effectively means it behaves private to anything outside the class, but it acts like a public variable to anything inside the class that's extending the class. So let's say again, protected acts like a private variable to anything outside the class. Like to our main function, it's private, so you can't access this. Whenever something is marked protected, it behaves like a private variable to everything outside the class, but it allows access to it to anything extending the class. So now whenever we got protected, notice that length can be used. Well, you may say, well, since it's a square, it could be the length or the width. So why is that red? That turns red. Why? Because in rectangle, length is protected, but this one's still private. So we might as well go ahead and make this protected too. So many times, and you always want to only provide as much you only want to provide as much access as what's necessary. So if you know that a variable is going to be used by another class, make it protected. Otherwise, leave it private. So now we'll change this back to length. Doesn't matter. Now here inside of this, we can just basically say this length or simply length, because effectively protected makes this a variable that's accessible inside of squares, or it's a class variable itself. So we go back over here to main. Note it, so to be clear, we're no longer calling side length just so side length can call get length from the rectangle. We're using length directly from the rectangle variable because square is extending rectangle. The constructor calls the rectangle's constructor, and then you have side length and side length. All right. So we go over here to main, then we hit run, and everything's just great, right? So everything is just absolutely great. So what I'm going to do is I'm going to show you well, what you should see, not show you, what you should see is that this is kind of a powerful thing. It allows very complex objects to be created from other complex objects, especially if in our natural world they seem to be kind of a special case of the other one. A square is a special case of a rectangle. It would make sense that the square should extend the rectangle. All right, so we have all sorts of shapes in the world that does this. So what if we were to talk about maybe different types of triangles? Notice that some triangles have two equal sides, and sometimes we have a right triangle. Sometimes we have an isosceles triangle. Sometimes we have an equilateral triangle. So in those particular cases, maybe if we want to subdivide a triangle, we could say, oh, this is an isosceles triangle, or this is a right triangle, or whatever. But they would all be extending a common triangle, perhaps. Many shapes do that. So shapes are just one example to where we have this. So another example would maybe where we have a motorcycle as a special case of a vehicle. A truck is a special case of a vehicle. A car is a special case of a vehicle. So what you might do is define certain methods for a vehicle, then extend them, and then utilize those in other places. So remember, super. Anytime that you want to reference something from the class, you use super. If you want to reference something from the square class, you use this. And in some cases, it'll be the same thing. Like this length, since it's protected, it's now part of square. So this or super length would work just fine, probably. All right, so all that said, that is kind of an introduction to extending Java classes. Hopefully this was helpful. Hopefully you guys felt like this was valuable. What I'm going to do is I'm actually going to push this up to a repository, and I'm going to maybe give it a feature branch that says square, special case, rectangle, and then you can look at how it changes. We're probably going to do another lecture video where we're going to like put these things inside of an interface, and we're going to show how to extend interfaces. And we're going to start creating some really specific objects here in the next few videos, okay? So we might just stay inside of this same repository and just cut off feature branches to show how we're going to progress from one to the next, okay? So with that said, thank you for watching. Hopefully this was informative, and I'll see you guys in the next video where we're going to be implementing interfaces and extending interfaces. So thanks.